Alright, welcome to our lesson today on instance variables, where we're going to be talking about how to create our very own robot class. So far in this course, we've been able to create and modify robots using code that we've found in the becker.jar package. But we haven't really looked into how that robot class is actually coded and whether or not we can code it ourselves. And we can, because that's the whole purpose of this lesson. So as we know, robots are displayed in a city. And cities are actually fairly complex in the way they're coded, because they can display a whole bunch of different kinds of objects, like walls, things, as well as robots, and so on. So we're actually, for the purpose of this lesson, going to be using a simple city that contains only intersections and robots. This will allow us to display objects in layers. So the first or bottom layer is going to be the intersections, and then on top of that we'll place a second layer, which will be our robots. Now, in order to display this stuff on the screen, we have to do this using a specific method called paint. And this paint method is going to act like the paint component method we've been working with in the swing class. So this means that everything that we're going to have appear in a city must have its very own paint method in order to work. Now, this paint method is found in the paintable class. The paintable class is a very basic and simplistic class that exists in the Becker package. It extends the object class, has a constructor that does only a call to its superclass to basically make an object, and then it has an empty paint method that we can override in any class that extends paintable. This means that anything we want to have showing up in a city must inherit or extend from that paintable class, so that we have access to that paint method. Now, cities are going to be displayed by constantly making calls to this paint method of the intersections and robots that are in that city. And it'll keep calling these paint methods over and over again at a rate of about 20 times a second. If in between calls to this paint method, a robot has moved from one intersection to another, where that robot used to be will have that intersections paint method called, so it displays an intersection there. And where that robot's been moved to, we'll have called its paint method, so that the robot is displayed in that new intersection. So we'll see how this is done is by creating a simple robot that is going to be at intersection 4-2 and can move and turn left. To do this, we need to know about its street, avenue, and direction. And this information is stored in what we call instance variables or attributes. So basically all the information about the robot will be stored in these variables. This means that each instance of an object has its very own set of instance variables. So all robots will have the same data types, but the individual data pieces will be different for each robot. So I can have a robot at intersection 4-2 and another one at intersection 0-0. The scope of an instance variable extends to the entire class. This means that the variable must be declared outside of any methods, but inside of the class itself. This would allow those variables to be accessed in any of the methods inside that class. The lifetime of these variables exists for the lifetime of the object as a whole. So as long as that object exists in my program, I can access any of the instance variables or any data about that object during my program's lifetime. So how do we draw a simple bot at intersection 4-2? Well, first we're going to assume that each intersection is 50 pixels square. So if I want to draw a robot that is 4 streets over, I do this by multiplying 4 by 50, because I'm moving 50 in pixels over 4 times. Same thing with avenues, where I'm going to multiply it by 2, so I can move 2 avenues down. So that's going to look something like this. My simple bot class is going to import from java.awt, so I have access to the drawing methods. It's going to extend paintable. I'm going to have my instance variables declared outside of any methods. I'm going to have my constructor that does nothing other than call the constructor for paintable. And I've got my paint method that is overriding the method found in paintable, allows me to set the color and fill an oval at intersection 4-2. So then when I run my main method, it's here. I've got a simple city, and I can add things to my simple city by using its add method, where I say what I'm adding and what layer I'm adding it to, and then I wait for the start button to be pressed inside my simple city. So if I run this, there's my robot at intersection 4-2. I hit start, nothing happens because I haven't set for it to do anything. So in order for me to move my simple bot from one intersection to the next, I'm going to have to increase the street or the avenue of that robot by 1. We have a problem. And that's because the way I've coded my robot is I've hard coded the values in here so that no matter what I do, I'm always going to be drawing my robot at intersection 4, 2. To change that, I need to access the information stored in my instance variables. So I'm going to do that by first giving them data. So inside my constructor, I'm going to initialize the data found in those variables. So my street is going to be 4, and my avenue is going to be 2. So now, when I draw it, I can access that information here. This is going to allow me to make my very own move method. It's going to look like this, where I'm just going to modify the value of my avenue. So if I compile and I go into my main class and I go smithers.move, we'll see that he's going to be able to move from one intersection to the next. So he's moving up one avenue here. Okay. Now we have another problem. Because if you remember, a city is redrawn 20 times a second. So that seems fairly quickly. However, it's not nearly as fast as it takes to execute a command in a program. It only takes 50 milliseconds to execute one move command in my program. So if I'm going to do more than one move command at once, I'm going to have an interesting effect of making it look like my robot is actually teleporting from one intersection to the other, because I'm not going to be able to see the individual move steps in between. So you see how I'm going, it looks like I'm skipping right over that intersection there in the center. So to fix that, I need to slow down my move method so it goes a little bit slower. And I do that using a method found in the becker.utilities package. So utilities.sleep. And I provide a parameter of the number of milliseconds that I want to wait before my next command is executed. So now when I run my main method, we'll be able to see the individual movements as I move south. So you can see here there's the code utilities.sleep, provide an argument of the number of milliseconds I'm going to have before resuming. But I still haven't taken into consideration direction, because no matter where I move now, I'm always moving down one avenue. So to figure out the direction I'm going to move in, I'm going to use variables, and I'm going to use integer data to represent this. So east is going to be 0, south is 1, west is 2, north is 3. This will allow me to make it so that every time I turn left, I just have to subtract 1 from the direction. And if my old direction is east, I just need to set the new direction to 3 to represent north. The problem is remembering which direction I'm working with can be confusing. So I can do this now by using variables to represent it instead. So I'm going to make a variable for east, south, west, and north, which is going to allow me to use just those words instead of the numbers when I'm discussing which direction I'm facing or turning. Now, because I don't want those values to ever change throughout my program, because if you changed what direction east was, if you made it like a 7 all of a sudden, the whole program is not going to work properly. So I need to make it a constant variable. This is indicated by using the keyword final and assigning an all uppercase characters for the name of that variable. And that will result in code that looks like this. So you can see I've added in a couple of instance variables. I've got my direction and each of the 4 actual directions of what they are. In my constructor, I've added the direction being set as east, and I've added in a turn left method. So if my direction is east, I'm going to set it to north, otherwise I can just subtract 1 from the direction. So now, when I compile and run my main method with a turn left method in here, we can see, well, actually, it's going to do nothing. Why? Well, because my move method still hasn't taken into consideration what direction I'm actually facing. So to do that, I just need to adjust the street and the avenue based on what direction I'm facing. So if I'm facing east, I'm just going to move up 1 avenue. If I'm moving west, I'm going to be changing my street by -1 and not adjusting the avenue at all. Same thing north and south, I'm going to make adjustments to the avenue, but not the street. So that will allow me to make code that looks like this for my move method. So you can see here that if my direction is east, I'm going to increase the street by 1. If I'm facing west, I decrease my street by 1. If I'm facing north, I decrease my avenue by 1. And south would be to increase my avenue by 1. So now when I run my main method, you should see that my movement is going to correspond to the direction that I'm facing. So you said I went east, turned left, and moved north, right? Now, we could also make that code a little bit more simplistic, because you'll notice that that code looked fairly repetitive, and we can do that by using helper methods, which ends up with a program that looks something like this. Simplebot2. So in this case, my move method, instead of having all that code in there, I'm just going to have my street being equal to what its street was, plus by what I'm going to change my street by. That street offset method is a helper method here. So I'm going to assume that I'm not changing my street at all. However, if I'm facing north, my street needs to go down by 1, and if I'm facing south, my street needs to go up by 1. I return that value. So depending on the direction I'm facing, I'm going to either add 0, -1, or +1 to my street value. And the same thing applies for avenue, using the avenue offset helper method. It looks like more code, but it's actually making the move method work a lot more simple, and I can figure out where my errors are by looking into if I have an avenue issue or a street issue. I can go here or here. One last thing we need to talk about is how are we going to know what values of particular variables are. Because you'll notice that what I've done is all of those instance variables have been made private. This is to make sure that the data stored in an object is contained or encapsulated within that class. It's like a black box. I don't want you to have access to any information about my class unless I give you a way to do so. I only want you to access it through methods that I provide. I don't want you to be able to go in and all of a sudden just randomly change what east is worth, or what the direction is, or what the avenue is, without having a method to do so that I've decided. So, to do that, we have to use what are called accessor methods. And they all have the same format. Public, the type of data you're going to give them, and then get and the name of the variable you want to send back. All that's in that method is a return method saying return and the instance variable. So for example, if I wanted to have an accessor method for street, it would look something like this. Public int get street. And all that will be in here is this dot, return this dot street. So now you can see what my street value is only through a way that I've given you access to see it. There's no other way to access this information. If you want to change it, you can only change it by using a way that I want, which would be to use the move method. That's it. That's all we have time for today. I will see you tomorrow where we can practice what we've learned.